Are you tired of being confused by science lingo? Want to amaze your friends? Or even just understand more about the world around you? Well, stay tuned while I run down a list of terms and facts in science that sound more confusing than they really are. There's an old joke that says, never trust an atom. They make up everything. Do they really? Atoms, as everyone knows, are made up of electrons, protons, and neutrons. But those are actually made up of particles themselves called quarks, and the gluons that hold them together. So this is an atom. Everyone knows that it is made up of electrons, positrons, and neutrons. But the positron and the neutron, however, are made up of their own things as well. Electrons are what are known as fundamental elements. They can't be made up of quarks. And the quarks are up, down, top, bottom, charm, and strange. And there are such things called gluons that hold them all together. So for example, a proton will have 1, 2 up and 1 down, whereas a neutron has the opposite charge. It's got 1, 2 down and 1 up. And then there are the gluons that help hold them together. These quarks are what's known as quantum particles. All that is if atoms is the atomic level, quarks are what's known as the quantum level. And like I said, there are up, down, top, bottom, charm, strange. That's just the names that we gave them. Don't put any kind of belief behind them. It's just something to call them, just to give them a set principle to know which ones we're talking about. Now that we know what the quantum particles are, let's talk about how they travel. Scientists believe they travel with a particle-wave duality, which simply means that they travel with properties like a wave, but they also propagate to a single point, only when observed. And I know that sounds weird, but it's what happens all the time. For example, they have an experiment called the double slit experiment, where they have a wave tank and a barrier with 2 slits in it, and then a back barrier to see the waves pattern. When they have the wave generator on, the waves come out, at which point, I can use 2 different pens to see it better. Here's one set of waves. It goes out, and anywhere where a peak and a peak meet, that peak gets bigger. Anywhere where a trough and a trough meet, that trough gets bigger. But anywhere where a peak and a trough of a wave meet, they cancel each other out. And what you are left with is an interference wave pattern, which simply states that the waves are interfering with each other in such a way that we get this pattern. Now, they did the same thing with particles. Here's a particle gun, 2 slits in the barrier, the back wall. Now, when they're observed, they take the particle, doesn't matter if it's 1 at a time or 100 at once. They fire the particles out. when they hit, they will hit in different locations. And what the scientists quickly realized is that the way that they hit did the same thing as the interference wave pattern. Small amount, bigger, even bigger, smaller, smaller, back down. Now here's where it really gets weird. When they don't observe it, whether it be a monitor, our own eyes, whatever, they fire the particles out. They literally will only propagate in two little bars behind where those are. It doesn't make sense, it's bizarre, but that's how it works on the quantum level. Also, particles on the quantum level can be quite ghostly. On the quantum level, particles can do something called quantum tunneling, which simply means their particles can go through barriers and objects to the other side, whereas on the atomic or molecular level, that cannot happen. It would need a certain amount of energy to move around it. Take, for example, this is the atomic level. We have a particle. We want it to get to here. Now, it would have to have enough energy and a low pocket of energy, almost like with the weather, how the weather moves, to go up and around it. Now, that's fine. Now, where it really gets spooky is we have on the quantum level, we have our particle. We want it to go here. It does not require any more energy than it takes to simply move in a straight line, because it can literally move right through. Now, people have that same possibility. It is much lower, near impossible to be able to do this. However, we do have the possibility of simply going straight through barriers. This thing actually happens inside of us by our enzymes. And when we have embryos still in development, moving its DNA around, propagating what things are going to be, these enzymes can literally go through each other. They have the option of going through the barriers to make their proper positions. The spooky property of quantum particles is that they can be connected no matter the distance. Quantum entanglement simply means that once two particles are bonded, like when a cell separates, those two pieces of that cell are bonded. Now, with particles in quantum entanglement, once they're separate, they are connected no matter what distance, to the point where one is on Earth, the other is at the edge of the universe. So we have two particles that are bonded. We have particle A on Earth. We'll say its spin goes this way. Particle B, their spin goes the other way. Now, the way that they are entangled is if one is on Earth, the other is on Saturn. If we take and we change the rotation of particle A at the exact time, this one changes its rotation without hesitation. Another example is, say that I have a dice and someone else on Saturn has a dice. My dice, I'm always supposed to roll a 1. Their dice, they're always supposed to roll a 6. Now, at the exact second that my dice lands on its 1, theirs will always be landing on a 6. really aren't sure what's happening on the quantum level, because most of it is too small for us to be able to see. They can be zooming around at every place at the same time, as well as in multiple states of matter and existence at the same time. Schrodinger's cat was actually just a very old thought experiment by Professor Schrödinger. He stated that if you took a cat and put it in a box with a piece of radioactive material, which is simply an element that emits an atom as it decays, and hook that up to a thing of poison, we would not know after a while whether or not that cat was alive or dead. So here's a diagram of the experiment. We have the cat. The piece of radioactive material is hooked up to the poison. Now, we leave the cat and the poison and the radioactive material in here. Now, his equation states that it's not that we don't know if it's dead or alive. It's simply that it is both until the point of observation, just like with the double slit experiment. This cat has the possibility of being both until the point to where we open that box, and then one of them will cancel out, causing the actual reality to happen. I know that sounds extremely strange, and so did a lot of the other things on this video, but on the quantum level, this is what's happening every second in our bodies, in space, all over the earth. Thank you guys so much for watching. Please click the like button, comment something you'd like to see me explain scientifically, and don't forget to subscribe and click the bell to be notified of all my new videos. Seriously, click subscribe and share my videos.